Okay, so this video is going to cover section 6.1, which is the area between two curves. And so this is just using the idea of integration where when we first introduce this idea, we talk about a curve, whatever that curve might look like, and we're going to find the area between two points somewhere. And so we're just finding this area under the curve, between the curve and the x-axis, if you will. In this section, we're going to have two curves, though. And so those two curves, we could have one that looks like that. We could have one that looks like that. And then we'll have our A and our B. And we want to find the area between the two curves. And so let's just call this one f of x. Let's call this one g of x. And so the way we can do that is we can find the area under this curve like we did up here. And so that would count all of this area as well. And then we can find the area under this curve and subtract it off. And that will give us the area between the two curves. So the area would be the integral from a to b, f of x minus g of x dx. So that's the basic idea. And it can get fairly complicated, but we'll keep it pretty simple in this class. So the first example we want to look at, find the area of the region bounded above by y equals e to the x, bounded below by y equals x, and bounded on the sides between 0 and 1. So let's kind of sketch this graph and see what this looks like. So y equals x, of course, is the diagonal line, looking like that. E to the x. Now, how do you know where e to the x might intersect, if it does at all? Maybe it doesn't. Well, we don't really have to know that in this case, because we know that if x equals 0, then e to the x would just be 1. So our y-intercept for e to the x is going to be 1. And then when x is 1, e to the x would be e, which is approximately 2.7, which is still going to be above this one. And so the rough sketch would just look something like that. And then we can draw this down. So that'll be where 1 is, and then 0 there. And so we're looking for this area between those two curves. And in this case, we didn't really need picture because it says we're bounded above by y equals e to the x. We're bounded, so bounded above, that'll be the top. Bounded below, that'll be the bottom. And we want to find the area between those two. And then, of course, between 0 and 1. So the integral from 0 to 1, and we're going to take e to the x, take the top curve minus the bottom curve. And it's a fairly straightforward integral. So the antiderivative of e to the x is e to the x. Antiderivative of x is 1/2 x squared. Evaluate it from 0 to 1. So we have e to the first minus 1/2 minus, now we'll evaluate at 0. So we have e to the 0, which is 1. And then 1/2 times 0 squared would be 0. And so then the answer is e minus 3/2 for that. All right, so look at the next one, which is similar, but they don't quite give us so much. So we kind of need to know a little bit about the graphs. So let's kind of sketch this. And the main thing you need to know is which, if they don't tell you anything about the graphs like we did in the first example where it said this bounded above by this one, bounded below by that one. You probably need to know kind of what the graphs look like. So y equals x squared is fairly well known. Y equals 2x minus x squared. So you can find the x-intercepts if you want. X-intercepts would be 0 and 2. And so we have 0, we have 2. And then, of course, this one opens down. So it's going to look something like that. And now we just need to figure out where that is. and that will tell us our limits of integration. And so we're looking for the area between these two curves, which would be that. So let's set these equal and see where these two intersect. So we'll bring everything over to this side. So we have 2x squared minus 2x equals 0. Factor out the 2x. And we have x equals 0, x equals 1. So that gives us the limits of integration that we need. All right, so now, and then this tells us that 2x minus x squared would be first, and then we'll subtract the x squared. So the area is the integral from 0 to 1, 2x minus x squared, and then minus x squared. So this is y equals x squared. This is y equals 2x minus x squared dx. And of course, we can combine our terms. 2x minus 2x squared. Do the integration. Antiderivative of 2x is x squared. Antiderivative of 2x squared would be minus 2/3 x cubed. Evaluate from 0 to 1. 1 minus 2/3 when we plug in 1, and then minus 0 minus 0 when we plug in 0. And then simplify that, and we get 1/3. And so that is a basic idea. So if you need a picture, and I would suggest you draw a picture when you're first getting started, draw the picture and use the graphing calculator if you need to. That can also help. But definitely draw a picture. And then the integration these are pretty simple. We're not getting super complex integration here, or super complex curves, for that matter. So that is it. We're subtracting the top curve from, or subtracting the bottom curve from the top curve, I should say, getting the area in between. All right, well, let me know if you have any questions.